Hey, how you doing? Welcome to today's lesson. What we're looking at today is tessellations. So, tessellations. Tessellations. My spelling isn't very good. I'm a maths teacher, not really an English teacher. Well, that's my excuse, but the thing is you should be good at both of them, okay? So, tessellations. Basically a tessellation. A shape will tessellate if it will able to tile an area. Okay? That's the easiest way to think of it. Okay, if the corners of the shape can fit together so that there are no gaps between them. So, for example, if I had rectangles tessellate very nicely because I can fit the corners of the rectangles together so that there are no gaps between them. Right? So that's a tessellation of a rectangle. And whether they're on top of each other or meeting the same or they're slightly offset. That's absolutely fine. You know the tessellations. You walk into your bathroom, if the bathroom is tiled, it's tessellated. If you look at a brick wall, that's a tessellation as well. Okay, so that's basically what it is. Alright. Now, the question is, how do you know if a polygon is going to tessellate? Because those tessellate absolutely fine, rectangles, but pentagons don't tessellate. When you tessellate a pentagon, you always end up with a little sliver of a gap. A very useful thing to do, especially if you've done it in junior school, is to go and get little cutouts of pentagons and try and fit them together so that they tessellate. Okay, regular pentagons. Right. So, how do we know if a polygon will tessellate? If its angles divide exactly into 360 degrees. So, if its angles are a factor of 360 degrees. So, the question is that I've got here: does a 9-sided polygon tessellate? Does a 9-sided polygon tessellate? That's a question mark. Okay, alright. Well, we have to find out what the internal angles of a 9-sided polygon are. Okay. So you can either go 180 times 9 minus 2 divided by 9 gives you the internals, or I can do external to the internal. I like going external, internal. So I'm first going to find out what the internal. So I find the external. External is 360 divided by 9. 360 divided by 9 is 40 degrees. Okay, and then my internal is 180 minus my external 40 gives me 140 degrees. Sorry, 140 degrees. Okay, right. So this is my internal. This is the guy that I'm looking at. Okay, that's the important thing. My internal. I don't really care about my externals. Okay, but I do care about my internals. My internals a factor of 360 degrees. So in order for it to be a factor, it has to divide nicely in. So let's try it. So now I'm going to say, does it tessellate? Well, let's see. 360 degrees divided by 140 degrees. Okay. Hopefully, I get 2.57. Right. So that means it's not a nice factor. All right. If I got 2, it would be great to be a factor. If I got 3, it would be great to be a factor. But I get 2.57 on my calculator. Yada yada, whatever. And it's not a factor. Okay. So because this is not a factor of 360, it does not tessellate. So a nonagon doesn't tessellate. It doesn't tessellate. Alright, because it does not divide nicely into 360. Okay. So then the next question is, okay, well, if this one doesn't tessellate, so show us one that does tessellate and show us why it tessellates. Okay. So I'm going to use the numerical concept to show why it doesn't tessellate, and I'm not going to draw it out, okay, because I wouldn't be able to draw it accurately anyway. Yeah. Alright, so e.g., does a hexagon tessellate, right? Now I hope you know that a hexagon does tessellate if you have to actually take those and put it down. Let's show why it tessellates, right? So does a hexagon tessellate? Alright, well a hexagon has 6 sides, so let's work out external, internal, work out tessellate. So the external is 360 divided by 6. 360 divided by 6 is 60 degrees. Okay, so then the internal, right, is 180 minus the external gives me 120 degrees. Alright, so the internal of a hexagon is 120 degrees. Fantastic. So this, okay, great. So does this tessellate? Well, I'm not sure. Let's try it. So now we're going to show that it tessellates. So to show that it tessellates, I have to do 360 divided by the internal, which is 120. Alright? 360 divided by 120, do it in your calculator, you get 3. Okay? So yes, a hexagon does tessellate because the 120 is a factor. So a hexagon does tessellate. Alright? Because the internal angle is a factor of 360. That's what you've got to look at. And if you think about it, a hexagon it does something like this. There's one hexagon, yada yada, up here, alright? Here's another hexagon, yada yada, over there. Oh, I haven't drawn this accurately at all, Mr. Roosh. There's another hexagon, and well, this is another hexagon over there. You get the idea. So they'll all meet at the point, at the same point, 120, 120, 120, okay? And so they all meet around that point, and so it does tessellate. Alrighty, super. That's about it with tessellation. It's pretty straightforward. Does the internal angle divide nicely into 360? If it does, then it tessellates. If it doesn't, then it doesn't. Occasionally, you might be asked about tessellations using two different shapes. Okay, so for example, you can tessellate a pentagon if you use another shape to make up the shortfall. Alright, you have to think about that. That's a little bit of extension work. About what shapes, how would I work it out? But the similar idea is this. If I took something off, what's left over, does a pentagon tessellate into that, for example. Okay, that's actually quite a cool thing to do as an extension, but go and check that out. Alright, go watch this again if you need to, but it's pretty straightforward. And remember, I'm here for you.